So let's spend some time now really thinking about what happened during the digital revolution, right? We have this foundation of network infrastructure. We have all of these different innovations and this like mindset towards thinking about technology as a catalyst for society. And so then what happens? Let's dive in. So the digital revolution really kicked into high gear in the 1940s, but we'd really been thinking about computing since as early as the 1840s. So if you've heard names like Charles Babbage or Ada Lovelace, right? These were early thinkers, mathematicians really, that were thinking about how to actually engage in this idea of mechanical computation, right? So these were analog computers. This is pre-digital at this point. From there, if we zoom up ahead a little bit more, during World War II, the sort of context of war actually ended up encouraging a lot of innovation that led to the modern computer, right? So in this particular image, we're looking at the Enigma machine as it was used by German forces to send encrypted radio messages during World War II, right? In the meantime, the US and allies were trying to think about different ways to actually crack those Enigma messages, right? So if you've heard of Alan Turing and you've seen maybe the movie The Imitation Game, right? This is the piece de resistance during World War II that was really developed by that crew, right? This was a machine that was now starting to actually think about systematically interrogating encrypted messages. Early computers in that sense were actually people, right? There were women who were working with these, analog machines and then eventually the digital machines. In this particular case, we're looking at the ENIAC, considered one of the first large-scale computers that was really revolutionary when you think about the history of computing. But as we started to introduce complexity and start to use these machines for more than just like simple calculations, it meant that you started to have this like explosive combinatorial issue where if one thing was broken, it meant that, right, you had to check 19,000 possibilities to fix a single bug. And so we were starting to really think about how to now simplify and reduce scale. So as this was kind of going on, in another part of our science and technology ecosystem, there were folks that were looking at trying to actually innovate on fundamental electronic components. In this particular case, the like revolutionary technology was this tiny little guy, right? This is the transistor. The first transistor was in the late 1940s, and this is a device that really helped us manipulate electrical signals, and it was actually a fundamental component of modern computing. This completely changed the way in which we were able to build devices, right? And then a couple of other groups started to think about, well, okay, if I can miniaturize a transistor, how can I now start to combine these pieces to be able to create more complex systems, right? So again, coming back up from, we simplified some of the fundamentals, now let's come up into sort of increasing complexity. In this particular case, we're looking at the first integrated circuit chip, right? So the IC, or the microchip as we now call it, right? Again, another fundamental component of the computer. As you can see this downscaling, right? On the left or on one end of this image, you can see what these early computers look like. And all the way in the woman's hands, you can see a small computer that is actually one of the later devices during this period of innovation in computing history. And underneath all of this was this concept called the Moore's Law. So Moore described this idea of the number of transistors and microchips and how you have this exponential doubling over time. And you can kind of trace the size of computers, the number of transistors that were able to actually fit on single chips from the 1970s through to modern times in 2020. And so this really meant that we were able to dramatically pack in a substantial amount of power, processing speed into these very small devices. And that also meant that the price of computers started to drop. This really set the stage for the democratization of computing, right? So early introductions to computers for the public were really through these like little DIY kits, right? This was the Altair 8800, which is considered a classic computer in computing history, right? It kicked off that personal computing revolution. It meant people were able to go to a shop, buy a computer, put it together, do some cool stuff. Sweet. Then came this entire suite of computers, right? So people started to innovate on the single item, starting to introduce different kinds of features, started to rethink the way in which we want to interact with it. And you have this explosive, right, increase of modularization when you're then thinking about the computer itself, right? We went from these monolith computers to something that was actually like a pick and mix, right? You could choose your own peripherals, you could choose your own devices, and you could really start to customize the computer so that it could do what you wanted it to do, right? So there's this idea of personalization that also started to come into play, right? And things got really radical there, right? Designers started to really have a lot of fun with what it meant to create computers for people, right? These were no longer just tools for war or tools for power. These were tools for fun, right? Yum. And so we're really seeing this like entire tree of computing change very, very quickly, right? From 1945 to the iPhone being introduced in 2007, a lot of really interesting things happened that I think it's really important for us to learn from and think about as we think about the future of computing as well. So if we look at some of the software innovations that were happening, right, they were very, I'm going to call them casual sometimes, very innocuous. You almost didn't think that this was going to completely change the way in which we lived and worked, right? People were developing operating systems to help us manage our files and write notes and play games. We were building tools for kids and really starting to really tinker and have fun with the idea of software. Software was a platform for innovation now. We then started to do work with it, right? You can kind of see the sort of rise and fall of different types of word processors. So we stopped typing. We stopped typing on typewriters and we started typing on computers. We started writing notes to each other. We started doing large scale, right? Data processing using spreadsheets, some of the coolest technology that still is around, right? And so it means that personal computing also then became professional computing. Sometimes it remained very personal, but it also meant that we were able to play and tinker with tools in a way that maybe we weren't able to before. And so we kind of went down this rabbit hole, right, where we started to build software, perhaps even potentially for the sake of it. It wasn't always clear where we were going, but we knew we were having fun and we were exploring the frontier of what it meant to innovate with digital technologies. Then came the internet. So let's go back a little bit, right? So in the 1980s, right, where now we've got computers are everywhere, they're in people's hands, but it means that researchers were also beginning to think about, well, how can we use computers in different ways? So the internet actually started as a set of connected research sites, in effect. So ARPANET was effectively an intranet. It was a private centralized network, right? It was this experimental networked infrastructure all over again. And as people started to sort of play with the idea of what it meant to connect computers across space, and then we started to then actually introduce different kinds of actors, right? So then universities came into the play. It wasn't just government research labs, but you can see in this particular map, this is in 1984, right? We introduced TCP/IP, which is a networking protocol, to then really start to be able to communicate among institutions. So again, this is where, if you've heard the names Vint Cerf and Robert Kahn, thought of as some of the founders of the internet, right? This is kind of what was happening. They were connecting computers even at research institutions. And then we started to think about how to actually make it more accessible. So I want to separate two things, right? So we just talked about the internet, which was really that physical infrastructure. At the same time, there was this other piece that was happening, right? Which is the digital infrastructure. So the World Wide Web, as described in this particular proposal by Tim Berners-Lee in 1989, described hypertext systems, literally hyperlinks, right? And so this was some of the first ways in which we were thinking about how to actually present information in browsers, on computers, that then took advantage of that large-scale network infrastructure that we just saw, right? And so this was actually one of the first websites, and it looks very hackery, but there was also a very user-friendly interface, right? But early on, we were just trying to see what we could do with this digital interface. And so if we come back to where we are now, right, we really have this large scale information network, right? We talked earlier about the importance and value and the power of network infrastructures. The internet is one of the most comprehensive network infrastructures of the modern age, right? This is a map describing the submarine undersea cables that connect literally every part of our Earth. We also now have satellites in space that add to this. And so it means that our connected infrastructure is now officially more than just the land that we have connected together. This set the stage for the democratization of information. Once people were able to start to use the internet, it meant that we were able to, again, start to tinker, have fun, and really think about what we wanted the internet to be in our lives. The 90s was a time of, I would argue, playfulness with the internet, right? We were still thinking about what we wanted it to be. It hadn't yet matured into this like professional platform necessarily. And so it meant people were doing things like writing guides for each other, right? Early corporate websites were fun and interesting because people were still playing with the technology, right? There was no defined way of using a website, right? This was an early White House website. But it also meant that there were some folks that were also thinking about how to use this platform for commercial innovation, right? So Amazon actually started in 1995 when they were just selling books on the internet. GeoCities in about 1995 was a platform for people to then produce their own content. And so you saw all sorts of goofy and interesting things being produced as, again, people were tinkering with the combination of the World Wide Web on that platform of the internet. AOL and a couple of other really important actors during this time really, again, helped catalyze the way in which we were using the internet. And I think for those of us who were around maybe during the 90s, these are things that we took for granted. But if you look back at their role in the history of the internet, they really changed the way we actually connected across space and time and really changed the way in which we were able to share information with each other. As we zoom out and think about where we are today, we have this vast connected network of information. This is one of my favorite art pieces about the internet. It's a guy used a piece of code called a trace route, and he used it to map every single connected device on the internet. And you can see in the corner, it says, WorldCom, Level 3, Sprint, AT&T, where you're seeing our networks of networks, right? We went from just having ARPANET to connected universities to, AOL and these like somewhat siloed but still slowly connected communities to now this entire organism, right? The internet it feels alive, quite frankly, right? Because there are things that are coming on and offline. We're able to create with it. We're able to make pockets of information. We're able to open up things we were never able to before. And so it means that we're sort of dealing with something that we have created. It is this large networked infrastructure. But there's a lot of potential for us to really sit down and think about what we want to do with it, right? Going back to this idea of as we design tools, as we design infrastructure, the reasons we design and what we do with it is very, very important, right? There's power for good and there's power for nefarious stuff. So some of us came a little bit to a head by the year 2000, also known as Y2K. In the year 2000, we were very worried about the end of the world. And I give this example, even though there's a lot of controversy about whether or not it was really a huge deal, right? I give this example because when we think about what we are experiencing today with modern technologies, this idea of fearing technology, of fearing the consequences of technology is, again, not new. We have gone through this many times, and how we deal with every time is interesting and different, and we can learn from it, right? So what was happening in the year 2000? In the year 2000, there was a very small and almost silly sounding bug, right? So you can see the date format up at the top of this slide, right? DDMMYY. That means there are 2 spots for a year. And so it meant when 1999 rolled over to 2000, everyone was worried that we were going to lose a bunch of information because computers might think that we had reset back to 1900, not moved forward to the year 2000. And this was a really big deal, right? I remember as a kid being like, oh man, what's going to happen in the new millennium? And so there were a lot of really proactive measures that people were sent out. I think Australia even invested millions of dollars in preparing for the Y2K bug. Some people did nothing. Some people did everything. Some people wore tinfoil hats, right? It doesn't actually matter what we did in a lot of ways. What matters is how we felt about what was about to happen. We were worried about the consequences of technology on our society. And that had dramatic impacts. So once we got over the year 2000 and nothing dramatic actually happened, we were able to then really think about what we wanted to do with the internet. This was a period of growth, especially in the context of internet-enabled commerce. We tried to sell anything and everything using the internet, right? It went from being a space for personal innovation to radical professional innovation. Right? Pets.com was one of those stars of the 1990s internet bubble or early 2000s internet bubble, depending on how you want to slice it. But there were a lot of issues as we started to sell anything and everything on the internet, right? In this particular case, the cost of advertising, buying and delivering the pet supplies actually exceeded revenue. And so it meant that while we were trying to use this platform, this technology, right, the internet, to be able to change the way in which we engaged with each other, we were not always able to think about the long-term impacts of what we were doing and why we were doing it. So, in this particular case, this is another one of those companies that kind of did not survive the bubble of the dot-com boom. Webvan stock rocketed up because everybody was like, oh my gosh, everything is possible. The rush expanding. Let's not even worry about profits right now, right? Everything was very short-term thinking. And then the moment they started to see that there was a dwindling customer base, there was this desperate struggle for cash, the stocks ditched. And this actually was like a massive deal when we think about what happened immediately after the sort of dot-com bubble, right? The dot-com bubble actually burst. And the 90s dot-com strategy, right, was kind of built on these three things. And I say this because it reminds me a lot of what we're experiencing today when we think about modern technologies, right? The 90s dot-com strategy was built on these three pieces. Big promises. We're going to revolutionize. Everything was about revolutionizing the way in which you mostly buy stuff, right? The second piece was everybody was really interested in getting big fast, right? So you're not really thinking about long-term growth. You're prioritizing short-term growth, saying, let's just sell at a loss, let's spend on marketing, and everything's going to be okay. And then the third thing that the people were relying on was this idea of like big stock market valuation, right? So investors were driving up valuation. There was an information asymmetry, and that kind of meant that you have this like really dangerous mix of hype, rapid growth, and short-termism. So when the bubble finally burst, you could kind of see sort of how much money had been poured into these dot-com companies, and the wealth vanished, right? Almost overnight, because people weren't really thinking about the long-term impacts or the long-term consequences of the way in which they were investing or even building the companies in the 1990s. This is important, right? Because when we think about what those companies did, right, they set the tone in a lot of ways for the way in which the internet grew after that, right? The dot-coms were, as they say, the training wheels for the internet. They really taught us how to live online. It meant that we were able to take for granted now that we can buy pet food on the internet after all. But after the bubble burst, it meant that we really had to sit down and think about those consequences and think a little bit more deeply about how we wanted to use the internet, right? There were many survivors, right? So Amazon is one of those classic examples, right? They really managed to find their niche and really hone in on it. eBay is another example. Netflix, amusingly, I don't know if most people know, was actually founded in 1997. It's actually not that new, right? But they really started to pivot the way in which they were actually selling their main business, right? It went from CDs to subscription services online. And so a lot of folks were really trying to play with business models more than necessarily the underlying technology itself, right? Priceline helped us move across spaces, another one of these survivors of the dot-com bubble, as well as some more familiar examples like Google. This tech sector growth, right? This idea of a bubble comes and goes, right? And so if you look at this particular chart, we're looking at the growth of IPOs, right? So international public offerings from 2000 to 2023. If the bubble happened in the year 2000, there were 397 IPOs that year. As we look at the current state of things, right? In the year 2021, there were 1,035 IPO offerings. That alone does not necessarily mean that there is a bubble, right? There are lots of other clues and other things that might help explain when and where a bubble might exist. But it does bring pause, right? Because we have to really start to ask ourselves again, like when we're designing technology, are we actually valuing it for the thing that it is doing, or are we valuing it for the sake of valuation? We've seen this changing role of technology, right? Where technology used to be this thing that was a support, right? So if we think back to those spreadsheets that we looked at before, right? The business was on one side and tech was on the other side. And this gap started to sort of come closer and closer. In the 80s, tech started to be a way in which we collaborated as we did business. In the 1990s, technology itself started to differentiate different kinds of businesses. And as we look at what was going on right now, technology actually is the business for many different kinds of organizations. Yochai Benkler writes this amazing book called The Wealth of Networks, and he talks about social production and how it transforms markets and freedom, right? And he describes this idea of this new networked information economy, right? The way in which we built the internet is now having dramatic and direct impacts on our economy. Information production has made human creativity and the economics of information itself completely different, right? And the thing that I really want us to focus on in this quote, right, is this idea of choice, right? There's no guarantee that networked information technologies will actually lead to the improvements that we want, right? He says that this is the choice that we face as a society, right? The way we actually develop technology, the way we actually develop as a society will depend on these choices that we make in the next decade or so.